All right, for the other questions, let's take a look at number 7. Number 7, it's pretty straightforward. Number 7 is just sine x times secant x, and you think about, what's secant x right there? Secant x is, 1 over cosine, right? 1 over cosine. So sine x times 1 over cosine x, and that's equal to tangent x right there. Okay, so answer will be B. Okay, so simple stuff. Okay, pretty easy to handle. Get you on a row. Okay, number 8. We say, what's number 8? Well, you have a cosine square x outside the parentheses. Well, what can you do? Well, there's not much you can do, I think. Now, there are actually 2 things you can do. Now, the first thing that got into my head is like, I think I can multiply the cosine square x into the parentheses. And if you do that, you have cosine square x secant square x minus cosine square x. Okay, and I'm like, okay, so if that's the case, cosine square x, it's cosine square x, and secant square x is 1 over cosine square x. And then we have cosine square x right here. Well, they would cancel each other out, so we have a 1, and we say, what's 1 minus cosine square x? What is 1 minus cosine square x? Well, I think we just saw it last video, or from the Pythagorean identity, right? 1 minus cosine square x is, well, ta-da, sine square x. Okay, so that will be answer choice C. All right. So now that's one way to do it. Now there's another way to do it. Okay. Now the other way to do it is that the other way to do it is that you may realize that, hey, does that look like the identity that you have to remember? That is the the 1 plus tangent square x is equal to secant square x. And if you say, let me move the 1 over, let me subtract 1 on both sides, what would that be? If you subtract 1 on both sides, that becomes tangent square x is equal to secant square x minus 1. So this is actually cosine square x times tangent square x. And that is cosine square x times sine square x over cosine square x. Okay, remember the tip number 1, just change everything back to sine and cosine, and you can see how they cancel each other out. So what's left? Sine square x. Same conclusion. Okay, the conclusion should not be different. Okay, should not be different. All right, so now number 9. What's number 9? Now, number 9, it's going to be very interesting because it's got a 4 power right here. So we are jamming in some prior topics like factoring stuff here, and we're saying, hey, can you guys figure something out? And we say, all right, so, well, it's the 4th power. So guess what? It's going to be secant. Well, this is the difference of 2 perfect square. So to help you see this better, so I can say it is the square, so you can see better here. And when you factor it, it becomes secant square x plus tangent square x, and then secant square x minus tangent square x. Now, if you say, wait, hold on, what's happening? I'm getting lost here. It is the same thing as a squared minus b squared, which becomes a plus b times a minus b. So it's the a and b, they are looking a lot more complicated. That's really it. Okay, and now, do we have anything special here? And we say, well, I think we do have something special here. I think it's from here, on the right upper corner, we have that identity. So what happens if we have the secant square x and tangent square x on the same side? Well, if we move the tangent square x on the right, so you have 1 equals to secant square x minus tangent square x. So this second parenthesis is essentially just 1. So we are left with secant square x plus tangent square x, and that's nothing we can do. This is actually our answer, which is choice F. Okay, pretty straightforward. Just to know that, ooh, that's fourth power. It's got to be some kind of factoring. Okay, it's got to be some kind of factoring. And number 10, we have cotangent x times secant x. Cotangent, it's what's cotangent? Cotangent, it's cosine over sine, and then we just think about this cosine over sine. Just changing back to sine and cosine, see how it works. And then secant is 1 over cosine x. Can you see something right there? See something we can do right there? We say, oh, hey, we can cancel things out. So we have 1 over sine x, which is essentially cosecant x. Cosecant x. Very, very, very straightforward. Okay, very straightforward right there. So that will be our choice A. All right, next up, we have number 11. We have secant square x minus 1. So if you had the earlier identity right there, right here, the right upper corner identity. So think about secant square x minus 1. What does that equal to? Secant square x minus 1 is equal to tangent square x. So the numerator is just tangent square x. The denominator is sine square x. Now, how do you simplify this? Okay, well, this is how you can simplify it. I personally do not like complex fractions, so you can change your view to this. And then you think about, tangent is what? Tangent is sine over cosine, right? Oh, well, tangent square x is sine square x over cosine square x. So so that's how you can simplify it, and then you have secant square x as the answer. Okay, that it's choice E right there. Okay, very straightforward. Number 12. So also a very nice one. We talked about this complementary angle identity already. Cosine of pi over 2 minus x. It's sine x. And sine x over cosine x is tangent x. So choice B, it's the answer. So for question 7 through 12, very straightforward. And just have to see all these identities and apply them. Okay,